आती होगी ना दोनों को। मुझे कुर्सी मिली थी पर इसमें इसमें जहाँ नीचे बैठे थे तुम। एक सेकंड यहाँ तो पहले से ही तो बड़े गेमर खड़े हुए हैं। जरा अपना स्टैक कार्ड दिखाना मुझे। गेमर का तो पता नहीं, लेकिन तेरे से बड़े थे। और स्टैक कार्ड में मंगवा लेता हूँ, ठीक है। बट तू 2 सीजन से कर रहा हूँ तो जरा वो ट्रॉफी दिखाना। क्या बहुत गलत हो रहा है। मैं क्या कह रहा हूँ भाई, ये नया लड़का कौन है? तुम्हारा पर्सनल बाउंसर है क्या? पिटपैट हो यार। कौन सा पैट है? पिटपैट। तुम गेमर एंटरटेनर सब लड़ो, मैं मस्त ट्रॉफी लेके घर पे जाएगा। सच। भाई जिसके नाम में मिथ हो वो सच बोल रहा है। रिलीज भाई कैसा चल रहा है आजकल? क्या नया चल रहा है आजकल? भाई अपना तो वही चल रहा है जो पहले वही वही चल रहा है, चाटा मारने का कॉन्टेंट। फॉलोअर कितने है? मतलब 3-4 मिलियन है। 1 मिलियन बढ़ाऊं? तो यहाँ सीट पे बैठकर तुम नीचे बैठने से अच्छा है।
My greatest strength is the freestyle. Come on, let me see you get down. Steady mama, this top.
बताओ।
Freestyle. Come on, let me see you get down. Steady mama, this top.
बताओ अपने बारे में। अरे बता दो यार अपने बारे में।
बेबी तुम्हारे इंटरव्यू का क्या हुआ? जॉब लग गई?
जॉब इंटरव्यू कुछ चल नहीं रहा है। मैं करती हूँ, देखो कौन।
बेबी तुम्हारे इंटरव्यू का क्या हुआ? जॉब लग गई?
कति बजे उठ्नुहुन्छ बिहान?
ओहो, त्यो त कुरै नगर्नु होला। मैले कहिले काहीँ खाना बनाएर 11 बजीसम्म पनि म त कहिले भोकै पनि हुन्छु। यहाँलाई उठाउँदा उठाउँदा अल्छी नै लाग्छ मलाई त कहिले त। अनि
कति बजे उठ्नुहुन्छ बिहान?
Kapil, can I speak in Hindi?
Yes, sir. Please, sir.
So,
Yes, Hindi, sir.
can I speak in Hindi?
Hindi, please.
Can you?
Can you?
Can you? Yes. Okay. Wow. Okay. I can speak in Hindi. So, give my regards to your Bebo and
Is it
love to
Hindi?
baby. Yes.
हिंदी पूछ के भी आप इंग्लिश बोल रहे हैं।
It's Hindi, right?
Only the Hindi is Hindi, sir. आगे पीछे इंग्लिश।
Everything is Hindi. Yeah, this is my style. Kapil, can I speak in Hindi?
Yes, sir. Please, sir.
So,
Yes, Hindi, sir.
can I speak in Hindi?
Hindi, please.
Can you?
Can you?
Can you? Yes. Okay. Wow. I can speak in Hindi. So, give my regards to your Bebo and
Go for today.
Call up any lead actress and they have to say, "Hey, Karan, it's me."
I only have words on this. Sona, I'm on coffee with Karan. You have to tell Karan that you have to just say hi, Karan. It's me. Say hi, Karan. It's me. Shah. Say hi to Karan.
Hello.
You say.
Hello.
Shah, say hi to Karan.
He has to say, "Hey, Karan, it's me."
Sona, say hey, Karan. It's me. I won. Please. मैं नेपाल तो नहीं गया, पर वहाँ की एक
बात बोल तो बाहर आके तुमने अलग ड्रामा करी हो यहाँ पे कि नहीं। हाँ, मेरे को नहीं बोलना चाहिए था, ये नहीं करना चाहिए था। अब आप क्यों ये सारी चीजें बोल रहे हो?
मैंने ये नहीं बोला था। मैंने ये बोला था कि अरमान जी ने वहाँ शो पे मारा, उस चीज के लिए मैंने बोला। ये
जब आप आए तो आप अगर अच्छे से क्लिप देख के आए हो तो आप सेंटेंस गलत कैसे बोल सकते हो? ये बताओ मेरे को।
सर एक बात बताओ, अगर मैंने ये भी बोला था, अगर तुम अपने लिए मतलब ठीक बोल रहे हो।
बात बोल तो बाहर आके तुम।
Hey guys, I'm going to show you how to make your skin naturally dressed appropriately.
Hi, Claire.
Hello, hello. How are we doing?
You just made me nervous. I thought, oh, she's not there. I was
No,
just
present and
trying
accounted
to.
for.
So ignore my email. Huh? There is sort of a
Okay.
last-minute email.
Yeah, no worries.
Thank you.
No worries.
So-
We'll probably still wait for a few minutes to see
Yeah,
if
you
more
wait
people
and
come in.
take more time. Just
Sure.
take more time, many breaks, and I will hang around again and then to answer questions.
Okay.
Okay.
Sounds
All right.
good.
Enjoy.
Thanks. I think we've got a mic on. Just letting a few other people into the chat. Okay, let's go ahead and make a start. This session is also being recorded, so you guys will be able to come back and rewatch this as you're working through the assignment. Okay, my name is Claire. Nice to officially meet you guys. I am the demonstrator for this subject. It's gonna do that. Yes, so I am demonstrating for the subject, and today we're going to go through the global climate change model that is absolutely necessary for your next few assignments. So I'm going to go ahead and share my screen here. Okay, so you can find the climate model through a few different ways. You can look at the invite for this meeting. There's a hyperlink in there, as well as the assignment instructions as well. There is a link there that will take you to this page that you're seeing now. So there's quite a bit in here and quite a few details about this climate model. Pretty much ignore all of it for the time being. What you're actually going to be interested in is just this top banner right up here. So it looks like a banner, but it's actually a button. So go ahead and click on that. All right, what you're going to get is a nice, simple menu here. And we are interested in this first one, the green one, deconstruct the mean climate. So go ahead and click on this one. All right, so the climate model is an incredibly powerful tool and can get quite advanced. And it's very, very useful, but for the purpose of this class, we're really going to just use the most basic version so that you guys can get an idea of what to look for, what to do. Sorry, I'm just going to let someone else in. Yeah, for these assignments. Okay, so once you've clicked that green button, you're offered two different options here. So what we're going to do is the basic version. So the standard version is more advanced. So there's just a lot more options, whereas the basic version is what we're really interested in. It's important to always choose the basic version because if you go with the standard version, you're going to get different answers to your questions. So when working on your assignment, please make sure you're using the basic version. It's incredibly, incredibly important. You're going to have different answers if you use any other one. So go ahead and click this one. All right, and you're brought right into it. So there's a few different things going on here. Along the top row, we've got two maps of the world. These are our experiments. And then this bottom one is the difference between the top two. So if we look at this top left one, this is experiment A. This is going to be essentially our control, our real world. And if you look along the left side here, you can see experiment A, and then all the different things that are checked. So when all of these are checked, it means that we've got the entire climate model present. So this is the current globe. So if you go through here, you can see that there's ice, there's clouds, there's the oceans, and then different parts of the atmosphere. So we've got CO2, and we've got the hydrological cycle as well. So it's important to have this left one, this experiment A, we're going to use basically as our control world. So make sure that these are all staying checked. And if you come on the right side of these factors here, you can there's descriptions of them. So if we look at CO2, for example, right on the right side here, if we click that, you can see a nice description. You can see a nice description of what it means by having CO2 concentration in the atmosphere. So if you read that, it's the atmospheric CO2 concentration changes the emissivity of the atmospheric layer and therefore changes the amount of thermal radiation absorbed and emitted by the atmospheric layer. The amount of change in the emissivity of the atmosphere layer also depends on the amount of water vapor and clouds because of the radiation absorbed by different trace gases or the clouds interact on a log scale manner. So it also says this will generally heat the surface. So from your lecture material, from general knowledge, from all sorts of different readings that you guys have had, you'll know the effects of CO2 in the atmosphere. But we can go through, so if I hit OK, that'll close that. We can go through and see a description of each one. And it's important to know the effects of these and exactly what's going to happen, what you think will happen once you take it out. Okay, so experiment A is our control world. This is our current world. We've got everything checked. Experiment B is more of our experimental world. So for now, we're going to go onto the right side. So you can see experiment A, we've got everything checked. Experiment B, currently we have nothing checked. And you can see there's quite a big difference between the two. So right now, let's go ahead and check everything on experiment B. Okay, so make sure that these are all checked. These are all checked. You can see that even though I checked it, nothing's changed. And that's because we have to go down to this orange button down on the bottom that says update figures. And this is really, really crucial that every time you change something, you hit this update figures button, because otherwise nothing's going to change. And again, your answers are going to be a bit skewed. So I've checked everything on experiment B. I'm going to hit update figures. Give it a second, and here we are. So you can see even just visually that the left one, which is our control, this is our experiment A, our current world, now perfectly matches experiment B. And you can see that that's changing, and that's just because we're cycling through the year here. So you can see it's January, we're now in March, going into May, and you can see that this slidey bar is what's controlling that. So you can see January is the beginning, and December's the end. So what we can do is we can hit stop on that, and you see it pauses. So currently we are in August, and I can move that. So if you take this little slidey bar, you can move that to the left, go all the way to January, way to December on the right. Okay, and this is really crucial because what you can see is, of course, the changes through the months, but using the maps, you can also see regional shifts as well. So if we were looking at, say, let's go to March. If we were looking at South Africa, for example, you can see that South Africa here is a nice shade of orange. And when you go to this color scale is the Celsius, right? So the degrees, sorry, the temperature. So if we're looking at South Africa, we're looking at in March, temperature is right around 15 to 20, maybe getting up to 25, all right? And then if I change that and I scroll all the way into, let's go September. All right, you can see that there's been a regional shift here. So you can see the southern tip is looking more like a low of 10 and a high of 15. So there's quite a bit you can do. You can shift around that. Same goes with the poles. So if you look at the northern, right up at the top here, you can see how it's very cold in January. That's because it's winter time over there in the northern hemisphere. And then if we move into their June, July, so that is the northern hemisphere summertime, we can then see that temperatures are a bit nicer, somewhere between -5 and 5. So you can see those regional shifts, but you can also see the global shifts as well. So if I take this slider and we go back to January, again, these are the same because our experiment B is all checked, experiment A is all checked, so they should be completely identical. So if I look at experiment A, right on the top of the map, it says that the global mean temperature is 11.3 degrees Celsius. So that's the global mean. And if you look on experiment B, it's going to be exactly the same, just because all of our factors are identical. And then we can pop down to this bottom map here. And the bottom map, right along the top, you can see that that's the difference. It's the difference between experiment A, our control, and experiment B, which is our experimental world. And so make sure that you're not using this, the bottom one, as your experiment B, because it's measuring the change between A and B, not B or A. It's the difference. So being the difference, and because of our experiment A and experiment B being completely identical, you'll see that right along the top here, you can see that the global mean, the difference is 0 because they are identical. All right, and if I go from January up to July, you can see that that global mean has gone up to 15.6 degrees Celsius. Again, the exact same in experiment B, and they're identical. Okay? Okay. So next up, let's go through and let's start removing and changing some variables. So experiment A, being our control world, we're going to keep all of these checked. All right, we're going to keep those nice and checked. We want to make sure that the climate model is complete, right? So our global climate includes all of these variables, so we want to make sure that everything is checked. But if we head over to experiment B, you can see, again, it's identical, but let's go ahead and remove something. So we'll use CO2 as an example. So if I go ahead and uncheck CO2, that means that the climate model is there minus CO2. So if we take CO2 out of the atmosphere, what happens? And of course, you can see still identical. And that's because we haven't hit this update figures button. So we want to make sure we click that. Okay. And you can pretty much immediately see that there is a difference, right? So if we look at our control, we can see that that's the same, general shifts. But as we move to experiment B, the one without CO2, you can see that even just visually, using the colors, that there's quite a bit of a difference, right? So if I go ahead and stop the time series again, and let's go to June, right? That says it right up there. So we're in June now. In experiment A, which is our control, our global mean is 15.4 degrees Celsius. But in our experiment B, the one that now doesn't have CO2, our global mean temperature has dropped significantly, and it's now at 4.44 degrees Celsius. And so then we pop down to this bottom map, you can actually visualize that change. And the color scheme here can be a little misleading. You have to be really, really careful but thankfully, it gives you a bit of a legend here. So we've got this color scale, right? Looks exactly the same as this one, but it means different things. So when you come over to the blue side, it says A is colder than B, right? But if you pop over to the right side, so more of the oranges, reds, and purples, it means that A is warmer than B. All right, so it's really important to go slowly through this and make sure that you know exactly what the interpretation is, because color-wise, you might think, oh, it's warmer than that. Make sure to take it nice and slow and focus on that interpretation of what you're looking at, because it's very easy to mess up and interpret things wrong. So if we look at this, we can see that the difference between A, our control, and B, our experiment, is 11 degrees Celsius. And the color scheme, if you go up to 11 degrees Celsius, right? So you can see that that means, sorry, just a second. Yeah, so you can see that difference on there as well. Okay, so if I went to, we're going to bring CO2 back. If I update it, it'll come back to being identical, right? And let's take out clouds as another example. We're going to update. You can see that this has a huge effect as well. All right, so you can see that our experiment B is very, very warm throughout the entire year, basically. So you can see that the global mean is now up to the 35 to 40 range, which is incredibly, incredibly high. And you can see that there's, on this map here, it means that A is colder than B throughout the year. And on average, colder by 23 degrees Celsius. Okay, so if I bring clouds back, let's go back to our CO2 example. We're going to hit update again. Okay, so this is our back to where again, the top left is our current climate, complete climate model. Experiment B is where now we don't have any CO2 in the atmosphere. All right, let's look at some of these regional shifts again. Okay, so what we can see, so let's go ahead and pause that again. Let's go into July. So July is, as we all know, winter down here. So in the southern hemisphere, it is our winter, and in the northern hemisphere, it is summer. So what we can see in July, if we were to bring back our regional example of South Africa, you can see that in July, normally temperatures are about 10 to 15 degrees Celsius. All right. And when there's no CO2, you can see that there's been quite a shift now. Hey, it's gone a bit colder. It's now looking more at the -10 up to 5 degrees as well. So you can see that shift. You can see just color-wise, major shift. And then if you go down to this difference table, careful because up here it means it's purple means it's warmer. But down here, if you look at this legend, that dark purple means that A is warmer than B by that much. So you can actually see that difference. Okay, so this is a great way of just visualizing it. And it's really important that before you guys start answering the assignments, work through this, put together some examples, see what it looks like. Look at those different regions, different areas, and see what changes and how much. When it comes to actually looking at the numbers, though, we can go up to these tabs. So this first tab is the maps. All right. If we go over to the second tab, time series, we can get a graph view of what that looks like. So if I come back to maps, we can see these global means, right? You can now see that in graph style. So along the x-axis here, we've got our timeline. So we've got January through to December. So this is our year. And then on the y-axis, we've got the surface temperature of the global mean. So that's the surface temperature across the world. The green line here is experiment A, so that's our control. And experiment B, again, is our one without any CO2. So you can actually see that change here between the two. When it comes to answering the assignments, we only want you guys to look visually at the graph and estimate. Don't download the data. We're not expecting you guys to work through that. We just want you to look at this graph and see that the difference between looking at about 12 and nearly 3. So you can see that the trend, when you take out CO2, the trend between the two is pretty similar. You still have higher surface temperatures right around July and August, and lower surface temperatures in the December-January period. So the trend is similar, but you can see there's this huge difference between the two, where our control with CO2 has a much higher global temperature than our one without CO2. All right. Okay. So it's really interesting, and it's actually quite a powerful tool as well, because you can kind of go in here and say, okay, well, what about if we, didn't have the oceans or an atmosphere? Then what? And that does not look like a great world to live in. So you can kind of work your way through this and see what it's like. Don't forget, there's also these descriptions on the right-hand side so that you can actually look and see, okay, well, what actually is ice albedo? You can look through that and see the differences. Another really key thing when it comes to the assignments as well is do some of your back reading. Make sure you understand the effects of sea ice. Make sure that you understand how clouds work, especially CO2, knowing exactly why CO2 is influencing the atmosphere and how it does. And then you can go into here and work through this example. Okay, so when it comes to the assignment, please make sure to read the instructions very, very carefully. Just take it nice and slow. Don't rush through it, because it's very, very easy. Like we talked about this difference graph, it's very easy to misinterpret what it's telling you and to get those questions wrong. If you're struggling with having it work, at all. So if you're struggling to bring it up at all, try a different browser. That might work. So like personally, I've found that Chrome generally lags for me, which is why I'm using Microsoft Edge on this one. And if that's not working, try and use a computer. You can try and use a computer on campus as well. That might work. Okay. I think that is everything. Do we have any questions about that?
Hi, Claire, it's Nadia here. I have a couple of questions for you.
Yeah, sure.
I think the first question is that this example that we are doing here with experiment A and experiment E all tick, but the carbon dioxide on experiment B, is that what we are required to do in our assignment 1, right?
So the different assignments will have different instructions for the effects of different ones. So just make sure that you're reading those instructions and knowing what's needed, because I think, yeah, CO2 is a big focus on this first one. Yeah.
Yeah, because I was a bit confused with what was required. And then...
Can I jump in, please?
Yes.
This is exactly how you need to do the settings for the first assignment.
Yeah.
The right-hand side, switch off CO2. So we don't want to confuse you. Claire showed you exactly what you need to do. Okay?
Yeah, amazing. Thank you so much. And then I have one more question, Claire. I'm having some like trouble trying to understand how does it work, the difference graph and the one on the bottom, the one that is the difference. So when you have the color, that color means the difference between A and B, like 20 degrees difference. Or...
So let me go ahead and we can work through another example of that to help with that one. So this one, you mean this bottom map?
Yes, yes.
Yeah. So if you look at the scale bar, you can see that this is the surface temperature difference. So this is the change.
Yeah.
On the left side, you can see that the more to the left it is, the more A is colder than B.
Yeah.
And if it's on the right, if the color scheme's on the right side, that means that A is warmer than B. So in this example, if we're looking at South Africa again, you can see that A is warmer than B.
Yeah.
Right? By about, it's looking like 16 to 18 degrees Celsius.
Okay.
So that's how you interpret that one.
Yeah, all right. Yeah, so that color is the difference in temperature between one and the other. Yeah.
Yes.
Okay.
Yeah.
Yeah.
Mm-hmm.
All right. Yeah.
Does that help answer your question?
Yes, it does. Yeah, it does.
Okay.
Thank you so much.
Yeah, no worries.
And I think those are my questions. Thank you.
Feel free to type questions into the chat as well. Yeah, I see we've got a question.
Hi, am I audible?
Yes, yeah, we can hear you.
Yeah, this is a really nice lecture today. Thanks for that. It is very interesting to me. My question is regarding to the assignment task. Is there any time limit for this assignment once it opened like a quiz?
There's no time limit, but I think you can remind me if I'm wrong. You can enter it as many times as you need to, right? But when it comes to answering,
7th of October, right?
Yeah, there's only a submission deadline.
Yeah.
Okay.
But when it comes to saving your answers, it might be best if
you don't see the answers. That will take, I think, another 3 days after the submission deadline. You get the response. You don't get an immediate response whether your answer is correct or not. You know, you have time, but you submit and then you get the results later on.
Okay.
Yeah. And if you think it might take you multiple times to come back in and continue answering, it might be a good idea to start just a separate Word document or something with all the questions, and then you can fill that in and then just submit it all, copy and paste them into the quiz itself.
Yeah, thank you. That's why I'm asking, because once I open, then I can let questions low. That's why.
Yeah. So feel free to open it and copy those questions into another
sure.
document and answer, and then pull them in if you need.
Yeah.
It's up to you. Yeah.
Thank you. Thank you, sir.
Mhm. Were there any other questions about the model itself, how to do it, or the assignment? This is your time to ask any questions that you guys might have.
I did not have a look at the questions yet of the assignment, so I might have more question, but I send you an email.
Hello.
Hi.
Yeah, I'm Imasha here. When actually it's looking like a previous our normal weekly quizzes. So after taking the quizzes, it shows that the time is counting. So after copying that, we can close or we can go back. Is that okay to do that, or is?
Yes. Yeah. I think there's unlimited number of attempts, right, Jochen? So you can come back to it.
Yes, you can do that, but I would just recommend that most things you can just do in one go. Because the more often you now try it, the more likely it is that you choose the wrong setting. So I would actually start the exercise, choose the right setting, and just go through questions one by one, and you can answer them all in one go. And there's one essay question where you have to write an answer. Most of the answers are just multiple choice. It offers you a, for example, temperature changes, whether it's -5 or +5 degrees Celsius. But there's one question, and for that, you need to know the answer. For example, why does CO2, or what does CO2 do? Does it cause a cooling or a warming? And why? Explain why. 100 words. So, and that will probably take a little bit longer for you. So you can answer most questions in one go. Most important is that you have the right settings of the model. And then you have one question where you need to do a little bit of background research. One tip, the assignment instructions have a one page at the end which actually gives you explanations. Don't just ignore this page. The assignment instructions have one page just with the introductions of how you have to choose the settings and so, but then there's another page with explanations. So, and many little things you will actually find on that page. All right. Oh, there's a thumbs up.
We got a thumbs up.
Me too. You're very nice students. Okay, is there anything still confusing? Because we had a similar session yesterday with the undergraduate students, and it all was very good. But then I got emails afterwards. One student asked me, "Oh, there is a question which talks about the temperature change in a specific month, in a specific region," and the student could not understand that by change, we actually mean the difference graph that Claire just showed you, the one at the bottom. The students thought that change is always between different times, a change from January to March or so. No, change is just meant in terms of the difference that you see. Mm-hmm. Okay, so that was confusing to some students. So just make sure that you understand change is in most cases, or I would think in all cases, refers to the difference graph that you see. whether a region is 5 degrees warmer or 5 degrees colder, okay? Due to a certain effect, and this one is due to CO2. All right, we don't want to confuse you. It's really, you know, like you saw it, that's exactly the settings you have to choose, and there are not that many options. Updating is always very important. And then you know, just take your time and choose the right month. You know, if it says January, then, well, if you look at June, then you apparently get the wrong answer. So you really just need to concentrate a little bit. And that's why I suggest do it in one go, because you can probably concentrate for 10, 15 minutes and answer most questions in that time frame, once you know what you're doing. All righty, any more questions? And nice meeting you, by the way.
Yeah, it was good session. Thank you so much.
Okay, and we will post the recording of the session on Flow in the next, I will do that in the next 10 minutes. And unless you have any more questions, then is it time to close the session, or do you have any question? I think we can.
I think we might be good.
Okay, thanks for attending the session.
Thank you, everyone.
Thank you very much.
Good luck with your assignment.
Bye.
You've got this.
Enjoy.
Thank you.
Thanks, Claire.
Yep.